Okay, so we're going to do 4.3 today, solve equations involving fractions. So by the end of today's lesson, you should be able to simplify and then solve more complex equations that involve fractions. Okay, so not a whole lot new here, but you do learn some new techniques. So a technique that can be used when you have two fractions that are separated by an equal sign is called cross multiplication. And this is an example of cross multiplication. So these are the characteristics. It has to be one fraction on one side, one fraction on the other side, and an equal sign in between. And this is the only case where you can do cross multiplication. Okay? So if that's true, one fraction, equal sign, then what you can do is you can multiply the top of one fraction by the bottom of the other, and then you can write equals, and then you can multiply the top of the other fraction by the bottom of the other. So let's start with the x, because we want to have our x on our left-hand side. So we would have x times 6. Well, we would write that as 6x, right? Equals 2 times 5 is 10. And I have now, ta-da, gotten rid of my fractions. So now it's super easy to solve this. I just divide both sides through by 6. And I end up with x equals 10 over 6, which reduces down to x equals 5 over 3. Okay, so you pause the video and try this one. So this one is a little bit trickier because you've got this negative in front of the fraction, and you have to put the negative either up in the top with the 2 or in the bottom with the 7, but not in both. So you have to make a decision. So I've decided I'm going to put it up there with the 2 so that when I multiply my y, it's going to be positive. So when I multiply y times 7, that gives me 7y. And that's going to equal 2 times negative 2 times 3, which is negative 6. And of course, then we're going to divide through both sides by 7. And y equals negative 6 sevenths. Done. Okay, so the general rule for cross multiplication is that if you have a over b equals c over d, then a times d is equal to c times b, or b times c. Okay? All right, so example 1. Solve 6 equals 1/3 times 8 plus a. So there's a couple of different ways you could do this. You could cross multiply, or you could think about opposite operations again. So remember what happened to the a. We added 8 to it, and then we multiplied it by 1/3. So the multiplying by 1/3, we could do the same thing. We could do, but in the opposite order. We could divide by 1/3 on both sides and then subtract a. Or, so that's one way to do it. Or we can use one of these two methods, which is finding the lowest common denominator of the fractions, which in this case is the 3. There are no other fractions, right? So you've only got one denominator. And then multiplying both sides by that common denominator of 3. So remember what I said, I think it was the other day, when I said if this is a third, it's like division by 3. If you're multiplying something by a third, you're really dividing that same thing by 3. And we're multiplying this whole thing by 1/3, right? Because the 1/3 is in front of the bracket. So I could think of it like this as well. So if I want to multiply both sides by the lowest common denominator, that would be really the 3. So I'm just going to multiply this 3 times 6, and then 3, and we're going to multiply this whole thing, 8 plus a over 3. I've changed it so that I don't have two sets of brackets when I'm multiplying. Okay, so 3 times 6 is 18, and I'm going to not distribute that 3 through. This is like 3 over 1, remember, and I could multiply the tops and the bottoms. But what I'm going to do instead, because this whole thing is being divided by 3, I can cancel these 3's. And I'm just going to be left with 8 plus a. And then I would subtract 8 from both sides. So let's do this. 8 minus 8 plus a is equal to 18 minus 8. Okay, so I subtracted 8 off of both sides, and I end up with a equals 10. Okay? All right. So that's not so bad, right? I decided to take the lowest common denominator. Another method that I could have used, and I already turned both sides into fraction. Well, I didn't turn the 6 into a fraction, so I will. So I've got 6 equals 8 plus a over 3. So I've already got one fraction here because that big old line covers both of the letters and numbers here. And I'm just going to make my left side a fraction. And then I'm going to cross multiply because I have one fraction here, and an equal sign in between. So 6 times 3 is 18. And then if I go to the other side, 8 plus a times 1 is just 8 plus a. So I end up with that. And then, hey, I'm in the same place I was before. So now I know what my answer is going to be, obviously. I'm just going to subtract 8 from both sides again. And then I get a equals 10. Okay, so I've got a here and 10 here. Okay, so I've solved. Okay. The other way, I'm just going to show you, I already talked a bit about it, was we'll throw it in here just because I brought it up. So 6 equals 1/3 times 8 plus a. So if I want to do the opposite operations that happen to the a in the opposite order, the first thing that I did with the a was I added 8, and then I took that whole thing and I multiplied it by 1/3. So if I'm going backwards, I'm going to take this whole thing and divide by 1/3. So it would be 6 equals 1/3 times 8 plus a, and then I'm going to divide by 1/3. On both sides, remember. Got to always do that. Okay. That in effect gets rid of my 1/3, and I would be left with 8 plus a on this side because those cancel. And 6 divided by 1/3 is the same as 18. And look at that, I get the same thing again. And then we do our minus 8 and minus 8 here. I'm just going to do it really super quick. I'm cheating. I'm putting it here. And it's going to be 8. A equals 10, but we already knew that. Okay? So 3 different ways to isolate your variable. And I don't care which method you use as long as your math is sound. All right. You guys go ahead and try this one. Pause the video. Use whichever method you want. So I'm quite partial to cross multiplication. So that's what I'm going to do. I could find the lowest common denominator. Well, I'll show you both. So I'll do cross multiplication first. So this is going to be 2. So I'm taking this times this and this times this. So 2 times b plus 3. I have to make sure I put that b plus 3 in a bracket. That's going to equal 4 times b minus 1. Another bracket. All right, we got 2b plus 6 when I do the distributive law, and 4b minus 4. And now I've got to rearrange things. So why don't I subtract 2b from both sides? So this is 2b minus 2b plus 6 equals 4b minus 2b minus 4. All right, so this is 6 equals 4b minus 2b is 2b minus 4. So now I got to get rid of that minus 4 attached. So I am going to add 4 to both sides. So this is going to be 4. And the plus comes because this was positive. My plus 4, the invisible plus is here on the 4. Okay, so this plus really came from the invisible plus that was here. And this is going to be 2b minus 4 plus 4. All right, whoopsie, plus 4. So when I clean that up, I end up with 10. That looks like a b, but it's a 10. Or it's a 6, sorry. So this is 10 equals 2b and dividing both sides through by 2 gives me b equals 5. Oops. All right, b equals 5. Let's try it another way and see if I get the same answer. So we'll try it a different way. I'll use a different color. I'm going to find the lowest common denominator of the two fractions. So I've got a 4 and a 2, and obviously the smallest number that both 4 will divide into and 2 will divide into is 4. So I'm going to end up with b plus 3 over 4. I'm just going to write it out. B minus 1 over 2. So I found my lowest common denominator was 4, and what I have to do is multiply both sides through by 4. Well, the 4's cancel in this case, so I can go ahead and cross them out, and I'm left with b plus 3 here. But they can't cancel here because I have a 4 here and a 2 here, but I do know that 2 goes into 4 2 times, so I'm just going to say 2 goes into 2 once, 2 goes into 4 2 times, and I'm left then with 2 times b minus 1. And when I expand that out, I get 2b minus 2, and now we've got to start getting rid of the b's on one side, so I'm going to subtract b from this side. And I'm going to do the same thing on this side, 2b minus b minus 2. Okay, so 2b minus 2 is just b minus 2, and this is disappearing, and this is 3. So then I'm going to get rid of the minus 2 by adding 2 to both sides. So plus 2 and 3 plus 2. So I end up with b equals 5. Yay, got the same answer both times. That's always refreshing. All right, let's do the next one. So this one looks super hard. Now, at any given time, you could just opt to do your distributive law with your fractions and then just gather up your like terms, okay? It's not wrong, but there are these shortcut sort of methods to get rid of fractions early on so that you're not using them throughout. But feel free to work with them. You could just take 3 halves times 3n, 3 halves times 2, minus 3 halves times n, minus 3 fifths times n, and minus 3 fifths times minus 5. And then just add and subtract appropriately to isolate your variable. You can do that. The other method then, the lowest common denominator, if I look at these two denominators, the lowest common denominator of 2 and 5 is 10. So I'm going to multiply both sides through by 10. But the first thing I'm going to do, I'm going to put it in a big old bracket. So there's my 10 and 3 halves. So I've got lots going on here, right? Because I've got a couple things being multiplied. And then I'm going to do the same on this side. So 10 times negative 3 fifths times n minus 5. Close that bracket and close the square bracket. Okay, so now I've got this thing. I've got 10 times this. So this is one thing times another times this other binomial. I've got 3 things being multiplied here. Okay, well, if I have 2 times 3 times 4, does it matter whether I multiply the 3 times the 4 and then multiply that answer by 2, or whether I multiply the 2 times the 3 and take that answer then and multiply it by 4? It doesn't matter what order I do the multiplication in. I don't have to go left to right, but what I would choose to do here is multiply the 10 times the 3 halves. Okay? I don't have to distribute that 10 in here. All I have to do is multiply it by one of these things, okay? And then whatever that result is, that's going to get distributed in there. So 10 times 3, that's just going to be 30. This is like over 1 again, remember? 10 over 1. So if I'm multiplying these two fractions, I end up with 30 over 2. And then I'm multiplying this by 3n plus 2. Over here, I'm ending up with negative 30 when I multiply tops by tops. over 5. Now, if I've done this properly, my fractions should disappear. Okay, I should not end up with any fraction denominators because I've chosen the lowest common denominator as 10 to multiply through. So 2 should go into 10, 5 should go into 10, and I should not have any fractions. So 30 over 2 is 15, and minus 30 over 5 is minus 6. And then I'm going to just do the distributive law. Okay, so now all I did there was I just got rid of my fractions to make it easier to work with the equation. So this is going to be 45n plus 30 equals minus 6n plus 30 as well. Oh, interesting. Okay, so I'm going to add 6n, say, to both sides. So this is going to be 45n plus 6n plus 30 equals minus 6n plus 6n. So I'm getting rid of the 6n on this side, or the minus 6n on this side. Okay, let's clean this up. So this is 51n plus 30 equals 30. That's interesting. And 51n then, when I subtract 30 on both sides, so I'm going to do minus 30, minus 30. Sorry, I'm just running out of room, so I cheated a bit. 51n has to equal then 0. And when I divide 51 on both sides, I get that n equals 0 divided by 51, which is just 0. So let me just I'm just going to check that one quickly. So if I put 0 in here, 0 plus 2 is 2, and that side is 3. If I put 0 in here, I get negative 5. Negative 5, I get 3. All right, I'm comfortable with my answer. Let's do cross multiplication. So I want to make sure I have that one line as my divided by sign. So I'm going to do this. This is 3 times 3n plus 2, and it's all being divided by 2. Okay? And I know you might not be that comfortable changing it at this point, but let's think about why that's true. This is, remember, like over 1. And I can remember I said you can exchange them. So this could be like 2 and this could be like 1. So this becomes 3 over 1 and this becomes 3n plus 2 over 2. Because it doesn't matter whether you multiply the tops by the tops, bottoms by the bottoms. It doesn't matter what order they go in. So you could literally physically switch them. Okay? So that's kind of what I'm doing there. So now I've got this fraction and I can just cross multiply. So I'm going to multiply 2 times this. So this is 2 times negative 3 and minus 5. I guess I really should have square brackets then. And this is 5 square bracket 3 times 3n plus 2. Now remember, I don't distribute that 2 all the way through. If there's a number here, that's what's getting distributed through, and I just have to multiply the 2 by the negative 3. So this is negative 6. And then n minus 5, and this is 15 times 3n plus 2. Okay, this is now I'm going, that looks like a t squared, sorry. Stop. I'm going to end up with, I don't know how that happened, negative 6n plus 30 equals 45n plus 30, and I'm going to add 6n to both sides. So this is going to be 6n and then minus 6n plus 30 equals 45n. So I'm adding 6n to both sides, remember, plus 30. Okay, so this becomes 51. N plus 30, this becomes 30. Okay, and then of course to get the plus 30, I need to subtract 30 from both sides. So 51n, something's going on with my equals 0. I'm sorry, it's changing colors. I don't know. It's doing it on its own. Divide both sides through by 51, and I get n equals 0. Okay, so there we have it. Let's do one more example. And I think this one is very important. So let's just look at it really, and I'm just maybe going to go back and erase this. You can see it a little better, although you have your copy. Okay, so this is k plus 4, sorry, k over 4 plus 1, and this is k plus 2 over 3. So the thing that's interesting about this is that you have two terms here. You have k over 4 and you have 1 being added. Over here, this is like one term. This is a binomial divided by 3, so that you consider this as one entity. Okay? The k and the 2 are being divided by 3. Over here, only the k is being divided by 4. Okay? So I cannot do cross multiplication because I have more than one fraction here. Okay? This is technically a fraction, right? A whole number. So I cannot just cross multiply. So I think what I should do is do the common denominator in this case. So I know my lowest common denominator of 4 and 3 is 12. So I'm going to multiply 12 by the whole left side, k over 4 plus 1, and 12 times k plus 2 over 3. Okay. I'm not going to cancel. I'm not allowed to cancel these the 4 and the 12. I can't just say 4 goes into 12 3 times because I've got this to deal with. The 12 is being multiplied by this and this. If there was a line under here and everything was being divided by 4, then sure, I could do 4 into 12 is 3, and then I would do my distributive law with the 3. But because it's not being divided here by the 4, I can't do that. So all I can do now is just, I'm going to do my distributive law with the 12. That's going to be 12k over 4 plus 12 is equal to, now this side I can divide the 3 into the 12 and get 4. So I'll do that. So 12k divided by 4 is 3k. 3k plus 12. And now I'm going to distribute 4k plus 8. Now I want to get the k's by themselves, so I'm going to go 4k minus 3k plus 8. And then I'm going to do 3k and subtract off 3k plus 12. So I've subtracted 3k from both sides to get rid of the 3k on this side. So I got k plus 8 equals 12. And all I need to do is subtract off the 8 then from both sides. And I'm finished. K plus 8 minus 8 and 12 minus 8. Okay, so I'm subtracting the 8 off and I get k equals 4. Oh, it says check. All right, well, let's just check this one. This is tricky. So I've got k over 4 plus 1. I have to go back to the original. Equals k plus 2 over 3. All right, my k is 4. So 4 over 4 plus 1 equals 4 plus 2 all over 3. So 4 over 4 is 1, 1 plus 1, and 4 plus 2 is 6, all divided by 3. So this comes out to 2, this comes out to 2, and left side equals right side, and we are happy. We know that k equals 4. All right, I do believe that is the end. Yes, that was a long lesson. Thanks for your patience.